Okay, I've decided to combine the last two tests because they're so similar, and the first is the comparison test. The comparison test, in words, I think is easiest to understand first because it's just intuitive. If you have an unknown series and you're comparing it to a known series, that's what you're doing with the comparison test. You're looking at an unknown series and you're trying to compare it to a known series that you know how it behaves. So if your unknown series is smaller than a known convergent series, so it's smaller than a convergent series, then the unknown series is going to converge. If it's smaller than a convergent that's known to converge, then it too is going to converge. Similarly, if an unknown series is bigger than a known divergent series, then the unknown series is going to diverge. So in essence, that's how the comparison test is working. Here's the formal theorem for it. And it's in words easier to understand, but if you have two series with positive terms and the AKs are less than the BKs, all right, and the BK converges, then the series AK is going to converge. Likewise, if you have a divergent series, right, and BK is less than your AKs, and BK diverges, then AK is going to diverge as well. So that's the comparison test. We'll do an example in a minute. But what happens when the unknown series is bigger than a convergent series or smaller than a divergent series? So you really can't use the straight up comparison test in that case, but we have something called the limited comparison test. And that test is going to be used when you have this scenario. All right, so if you have a scenario when an unknown series is bigger than a convergent series or smaller than a known divergent series, we're going to use the limited comparison test. And what you do is you take the limit of the ratio of the two series. So you're going to take the limit as k goes to infinity of the AKs to the BKs. All right, and if you put the known series in the denominator, it helps, I think, to makes it a little easier to do the problems and interpret the results. So if you end up with a finite number for that limit, then the series are going to converge or diverge together. So in other words, if the known series converges and that limit is a finite number, then your AK is going to converge. If your series of BKs diverges, then, and it equals, the limit is a finite number, then they're going to diverge together. If it equals 0, if it turns out that L is equal to 0, and you have a convergent known series, then your unknown series is going to converge. And also, if you have the limit equaling infinity, and your known BK series diverges, then the unknown AK is going to diverge as well. So that's how you interpret the limit value. So let me go off and find an example of both of these. So the first example I have here is the series 1 over k squared plus 4. And hopefully you notice that this looks like a p series. It looks like, and that's where the comparison test comes in. You have to determine what the series looks like. It looks like a p series. Specifically, 1 over k squared is a p series with p equal to 2, right? And we know that's a convergent series, right, because it converges for p greater than 1, right? So p greater than 1, that's going to converge. So it's a convergent p series. So I could list the series to determine if it's less than it, and I will. So let's take a look at it. K equals 1 to infinity, 1 over k squared plus 4, and list a few terms to see what's going on, right? And then list the p series. you can see that, each of the terms here is less than, right, the P series. So this top series is less than this bottom series. Okay? So since the series that we're looking at, the unknown series, if you will, is less than a known convergent series, which is the P series. It's a convergent P. And since our unknown series is less than that, then the series is going to converge by the comparison test. So this is convergent by the comparison test. I'm going to pause there for a minute and look for a limited comparison test. And it's that simple, right? You're looking at your unknown series, you're trying to determine what it resembles, okay, whether it's a convergent or divergent series, and then set out about your comparison of your individual terms, okay? And that's it. That's the comparison test. I'm going to pause. Okay, so here's our next example. It's this infinite series with k squared minus 1 over k cubed plus 4. So this series looks like, we're going to take the powers out here, k squared over k cubed. When you reduce that, it looks like the harmonic. And we know that the harmonic diverges, but I'm not sure if it's smaller or bigger than the harmonic, right? So, because you got a subtracting of terms up top, you got an addition on the bottom. So I'm going to use a limited comparison test. Okay, and this is, of course, the divergent harmonic. There's only a handful of known series that you know at this point. Right, the harmonic being one of them. And of course, that's just a special case of the P series. All right. So looking at this, I'm going to set up the limit. And I'm going to put the known series in the denominator. So I'm going to take the limit as k goes to infinity. The unknown series up top divided by the known series, which is the divergent harmonic. And I'm going to algebraically clean this up. And this is k times k squared minus 1 over k cubed plus 4. And I'm going to distribute in that term. Get k cubed minus k up top and k cubed plus 4 on the bottom. Now you would divide through by the highest power, or just notice that this term and this term have the same power, so the limit is the ratio of the coefficients, which is 1. So since the limit is a finite number, it's a finite number, so the series are going to converge or diverge together. So in particular, this series diverges. It's a finite number, so I guess let me put the rule first. The series converges or diverges together. And we know it's a harmonic, and a harmonic is divergent. So our unknown series is going to diverge. So k squared minus 1 over k cubed plus 4 diverges. Specifically, diverges because 1 over k, the harmonic series diverges. By the limited comparison test. Okay. So I know it's a 10-minute video, but we got 2 tests, so they're each about 5 minutes. Okay. I'm rationalizing.